Hi, and welcome to Topic 10. Today we're going to be discussing finding segment lengths in circles. So all we're going to do in Topic 10 is look at what happens when those segments intersect inside the circle. So to begin, if we look at our lovely picture, I use this lovely thing to remember it. Now if I had a circle or a ball like this and I threw it at someone, it would pop them on the head. So I kind of remember it by pop, pop. And what that POP stands for is product of the pieces. Now I'm going to take it one step further and I'm going to highlight. When I look at this, I see that I have one segment CD in green and one segment AB in red. So I'm going to separate them and I'm going to say AE times EB equals CE times ED. So I took each segment length and I broke it up into little pieces. So when I look at this, I just remember it by pop because I'm going to pop you in the head with it when you get hit with that ball. So let's do some examples. Over here, I'm going to highlight my segments just because it helps me. I'm going to highlight this one in red, and I'm going to highlight the other one in blue because green ends up being a little hard to see when we're writing. So when I set up this equation, I'm going to look at the red line first, and I have 9 times x. And what does that equal? In blue, it equals 6 times 12. So when I actually do the math, 9 times x is 9x, and 6 times 12 is 72. I divide both sides by 9, and x equals 8. So over here, I'm going to do the exact same thing. I'm going to highlight my segments, one red and one blue, because I want to stay along the same line to set this thing up. So I have 27 and x plus 5 is equal to, on the other side in blue, I have 2x times 21. So when I do the left-hand side of my equation here, I'm going to have to distribute. When I distribute, I get 27x plus 135 equals 42x. So I'm going to subtract 27x on both sides. When I do that, I bring down my 135 and I get 15x over here. So I'm going to divide both sides by 15 and x equals 9. Now I'm going to look at two more examples. Once again, I'm going to highlight both sides. There's my red highlighter and my blue highlight. So when I look at the red, I get 21 times x plus 12 equals, and in blue I get 18 times x plus 14. So what I'm going to do next is I'm going to use my distributive property to go ahead and solve this, and I get 21x plus 252 equals, distribute on both sides this time, 18x plus 252. So I'm going to subtract 18x on both sides of my equation. I end up with 3x plus 252 equals 252. I subtract 252 and 3x equals 0. So when I divide by 3, x is just going to be 0. last example. I'm going to start out highlighting again. Highlight one in red and one in blue. I normally do that so I don't get this confused. So I'm going to start out and I'm going to say, okay, well, what's on red? I have 6x times 10x. And that equals 27 times 20. So now I'm going to multiply on both sides. On the left-hand side, I have 60x squared because x times x is x squared. 27 times 20 is 540. I'm going to divide both sides by 60, and x squared equals 9. So now here's the tricky part. I need to get this x squared by itself, so I'm going to take the square root. When I do that, I get x equals plus or minus 3 because I took the square root, but I can't get a negative value here. So I can't say this is negative 30, so I know that negative 3 doesn't work. So x equals just positive 3.